Hey, 7th grade. We're going to begin a new unit with this video, and in this new unit we're going to learn how to simplify algebraic expressions. That's what this unit is going to be over. I'll remind you of this in class as well, but for this unit you will be allowed to use basic calculators. So I'm going to allow you to use basic four-function calculators, ones that add, subtract, multiply, and divide. You will still not be allowed to use your graphing calculators yet. If you have just a basic calculator at home, you can bring that in if you'd like to, but we're still not going to use graphing calculators yet, just because there's a few things that I still want you to know how to do before we get into those graphing calculators. For this video here, you're not going to need a calculator at all, but for the ones coming up in the future, a couple videos from now, you may want to have a basic handy. Okay, this video, it's going to be pretty short compared to some of our others. We're just going to talk about classifying real numbers. If you remember in the last video we talked about how to compare real numbers, and I told you I'd explain what a real number is in a later video. Well, this is that video. We're going to talk about this term real and what makes a number real. And so we're going to talk about the different sets of numbers. All numbers can be classified into different sets, or sometimes we call those families of numbers, based on their characteristics. And so you may have talked about this before in 5th or 6th grade. You may not have. So depending on whether or not this is new or not for you, I'm just going to treat it as if you never heard of it before. Okay? So the first set of numbers that we have are what are called the natural numbers. Sometimes we call those the counting numbers. And those numbers start with the number 1, and they continue on to 2, 3, 4, 5, 6, etc. Okay? So these numbers are all the positive numbers, and they don't include fractions or decimals. The reason we call those the natural numbers is because those are the numbers that when you first learn how to count, those are the numbers that you start with. Okay? So numbers 1, 2, 3, 4, on and on and on, those are part of the natural numbers. We then have a set that's called the whole numbers. The whole numbers include the natural numbers. Okay, so 1, 2, 3, 4, 5, 6, on and on are all part of the whole numbers. But for the whole numbers, we add the number 0. Okay, so the characteristics of this set is it contains all of the natural numbers. And the only difference between this set and the natural numbers is that we include 0 in with the whole numbers. Our next set of numbers include all of the whole numbers. Okay, so if you notice, these sets keep building on each other. Okay, so all of the natural numbers are in the whole numbers, and now all of the whole numbers are going to be in this next set. But now we're adding in the negative whole numbers as well. And so when you take all of the positive whole numbers, all of the negative whole numbers, and 0 and put them together, you get the next set, which is called the integers. Okay, so the integers include all of the whole numbers, and now we also include our negative whole numbers. Okay, the next set of numbers we're going to expand even more now. Okay, so the next set of numbers is going to include all of the integers, but now we're going to include everyone's favorite type of number, and that would be fractions. Okay, so this next set of numbers is what are called the rational numbers. And so these include, again, all of the positive and negative whole numbers. It includes 0, but it also includes any number that can be written as a fraction. So for instance, 2/5, that would be a rational number. We also include terminating and repeating decimals, because all terminating and all repeating decimals can be written as fractions. So an example of a terminating decimal would be 5.45. Okay, that is a rational number because it stops after the hundredths place. And also you could write that as a fraction if you wanted to. That would be the same as the mixed number 5 and 45 100ths. So terminating decimals are rational numbers. Repeating decimals are also rational numbers. So 0.3 repeating is a rational number because it can be written as the fraction 1/3. Okay, so all terminating, all repeating decimals, and all fractions are part of the rational numbers. The last set that we're going to talk about, and this set does not include anything before it, so I'm going to do this in a different color just so you can see that. Okay, so this set does not include the naturals, the wholes, integers, or rationals. This is what we call the irrational numbers. And so if you're irrational, that means you're not rational. So it's going to include all of the numbers that are not in this rational number set. Those numbers would be numbers that cannot be written as fractions, and typically you're going to see that in one of two ways. You're going to see it as a non-terminating, non-repeating decimal. So if you see a decimal like, oh, I don't know, this, 0.145763823 ... Okay, that number continues, but there's no really pattern to it. There's no repetition, so that would be an example of a irrational number. A very common irrational number that we see often, especially in geometry, is the number pi. Okay, pi we approximate to 3.14, but really it's a decimal that goes on and on forever with no pattern, so it's irrational. And anytime you see a square root of a non-perfect square, for instance, the square root of 10, that is also going to be an irrational number, because if you type the square root of 10 in on a calculator, you're going to get a decimal that eventually looks like it stops, but that's just because your calculator is going to run out of room. So all of your square roots, with the exception of square root of 9, square root of 16, numbers like that, are also going to be irrational numbers. So now we're going to go on to these examples at the bottom, and we're just going to look at several different numbers, and we're going to classify them into which family they belong to. By the way, I told you I was going to tell you what this term real up here means. If you take all of these sets of numbers and put them together, so the rationals with the irrationals basically, if we combine all of our rational numbers with all of our real numbers, with all of our irrational numbers, then we get what are called the real numbers. So the real numbers are basically any number you can think of, and it would be all of the rational numbers combined with all of the irrational numbers. So every number that we see is going to be a real number. Okay, now let's go to examples 1 through 9. So we're going to name the set or sets, because they may be in more than one, of numbers to which each of these numbers belongs. So let's start with negative 12. Okay, negative 12 belongs not to the natural numbers, because natural numbers, again, don't contain any negatives. It does not belong to the whole numbers either. Whole numbers don't include negatives, but it does involve to the next set of numbers, which are the integers. So negative 12 is in the integers. It's also in the rational numbers. If you're in the integers, you're automatically in the rational numbers. Okay, if we go back to this chart here, if I start in this top row here, if I'm in the natural numbers, I'm automatically in the next three sets as well. I'm automatically in the wholes, the integers, and the rationals. If I'm a integer, then I'm automatically a rational as well. Okay, so you just work your way down, and these sets keep building on each other. So negative 12 is both an integer and a rational number. Okay, 5/12. Well, if you go back to your chart here, it's positive, but we don't start including any kind of fractions until we get down to the rational numbers. So 5/12 is only included in one family, and that would be the rational numbers. Okay, negative 4.67. This is a negative number, so you might be tempted to say it's in the integers, but remember, integers only include positive and negative whole numbers. Okay, we don't include the fractions or the decimals yet, so negative 4.67 is actually a rational number. That's the only set it belongs in. It's a terminating decimal, so that's why we can put it in the rationals. Okay, 6. The number 6 is actually a natural number, because if we start counting 1, 2, 3, 4, 5, 6, we're going to hit this number here. And if it's a natural number, that means it's automatically in these next three sets as well. So it's a natural number, it's also a whole number, it's an integer, and it's a rational number. So 4 sets for 6. The number square root of 57. Well, square root of 57, if you want to check on a basic calculator, you can. If you type in the square root of 57, you're going to get a long, non-terminating, non-repeating decimal. Okay, it should be 7 point something, okay, around 7.5, maybe a little bit more, a little bit less than that. But it's going to be a not nice decimal, and that's because there is no number times itself that gives you exactly 57. Okay, so if you remember, we talked about the square roots. Unless it's a perfect square, these are going to belong to the irrational numbers. So square root of 57 would be in the irrational numbers. Square root of 9, on the other hand, 9 is a perfect square. The square root of 9 is really just equal to 3, so that means that the square root of 9 is a natural number because 3 is natural, and it's automatically a part of the next 3 as well, the wholes, the integers, and the rationals. So just because you see a square root doesn't mean it's irrational. If it's a perfect square, then it's going to be in these 4 sets right here. Same thing with 16 over 8. 16 over 8, you may at first glance say that's a fraction, so it's in the rationals. You'd be correct, but it's in more than just the rationals. 16 over 8 means 16 divided by 8, which is the same thing as 2, and 2 is in the naturals, the wholes, the integers, and the rationals. Negative 1/2. Okay, at first glance, again, you may say this is an integer, but remember, integers only include whole numbers. So negative 1/2 is actually just going to be in the rational numbers. And then the last number we have is 0.8, and then the 9 is repeating, because we have that bar up there. Repeating decimals, remember, can be written as fractions, and so they are part of the rational numbers as well. So repeating numbers are also part of the rational numbers. Okay, so that's all this video is going to be over. We're just talking about how to classify numbers into the different sets. If you have any questions, be sure to jot those down on your paper, or you can also make a comment on this. If you're logged into your Google Drive, you can make a comment on this video to ask your question there. So until I see you next time, have a nice day. You're all wonderful people.